Hi everybody, this is Nageswara, Assistant Professor of Physics, Government Degree College, Chintalapudi. In this presentation, I want to analyze intensity of electric field due to the charge sheet using Gauss law. So before going to the intensity of electric field, once again we want to remember what is Gauss law. We know Gauss law states that the total number of electric lines of force, that is total flux, is equal to 1 by epsilon naught times of total charge within the closed surface. So that the total flux pi is equal to integration E dot ds, that is equal to integration E ds cos theta, that is equal to q by epsilon naught, where theta is the angle between direction of intensity of electric field and surface normal to the surface ds. Now, our aim is to calculate intensity of electric field due to infinite charged conducting sheet. So, what is? Of course, we cannot draw infinite sheet, so that in this figure I want to draw a finite charge sheet, in which the total charge q, that positive charge q, is given to the surface area, and if sigma is the surface charge density, then sigma is equal to q by s, or q is equal to sigma into s. What is surface charge density? Surface charge density can be defined as the charge per unit area is called surface charge density. So, the surface charge density the surface charge density sigma is equal to q by s. So, charge by unit surface area, according to that q is equal to sigma into s. You know, when we want to apply Gauss law, we require a closed surface. For this purpose, here we want to draw a Gaussian surface that is in cylindrical shape. Here you see, in this diagram there is a charge sheet, and this is the Gaussian surface in the shape of cylinder. So, for this purpose, even we can draw a cylindrical Gaussian surface, that is taken as A. The direction of the electric field near the surface is perpendicular to the surface, as conducting surface is an equipotential surface. We know, according to this, the line of forces or electric flux passing through the two ends of the curved surface of the Gaussian cylinder. At the top of the cylinder, E is perpendicular parallel to ds along this direction. Along this direction, there is E is there, where electric field E and ds is parallel to each other, so theta is equal to 0. And bottom end, there is no lines of forces, so the intensity of electric field is 0, or flux is 0. And at the curved surface, there is also number of no lines of force will move along this direction, so that in which the flux is also 0. Now, what is the total flux? The total flux pi is equal to flux at the top end Now, the total flux pi is equal to flux at top end, that is integration E dot ds at top end, plus integration E dot ds flux at bottom end, that is integration E dot ds bottom end, and plus total flux around the curved surface, that is integration E dot ds at curved surface. But we know there is no flux at bottom end, there is no flux at curved surface. So, this is 0, this is 0. So, the total flux pi is equal to integration E dot ds, that is equal to integration E into s, because integration ds is equal to capital S, that is total surface area of the sheet, charged sheet. Now, when we apply Gauss law, according to Gauss law, we know pi is equal to integration E dot ds, that is equal to q by epsilon naught. But we know q is equal to sigma s, so that E into ds is equal to sigma into S by epsilon naught. When SS cancel each other, the intensity of electric field capital E is equal to sigma by epsilon naught. So, the intensity of electric field due to the charge sheet are infinite conducting charge sheet is depending on the surface charge density sigma. So, the intensity of electric field of a infinite conducting charge sheet is equal to sigma by epsilon naught. Thank you.